So let's talk about maybe the hardest job in all of audio. You're in a movie theater, right?
Mhm.
A building is collapsing on screen, just this huge floor-shaking bass. But at the exact same time, an actor whispers a line that's critical to the plot. How do you even begin to stop that massive explosion from just completely swallowing the whisper?
That really is the holy grail of cinema sound, isn't it? And, usually the answer is just throw more power at it. But when you look at something like this QSC SC-414, the answer seems to be more division.
Right, because that's the first thing that jumped out at me from the specs. It's a four-way screen channel loudspeaker. I mean, most home systems are two-way, maybe three-way if you're lucky. Why four? Why slice the audio into four separate pieces?
It all comes down to preventing something called coloration.
Hmm.
Think about a simple two-way speaker. Your main woofer is trying to do deep bass and lower mid-range at the same time.
Okay, so it's doing double duty.
Exactly. So when that huge, like 33 hertz explosion hits, that speaker cone is moving like crazy. If it's also trying to reproduce a human voice at that moment, that violent movement it distorts the voice. It muddies it completely.
So the SC-414 is giving every single frequency range its own personal specialist.
That's the whole idea. You have the LF4115 component that's handling all the heavy lifting at the bottom end. And then the MHV1090 unit takes over for everything else, splits the rest into mid-high and even very high frequencies.
Very high. That sounds like we're getting to the absolute edge of what a human can even hear.
We are. It goes all the way up to 20,000 hertz. But the magic isn't just hitting that number. It's how it gets there. And this is where the notes on the low distortion waveguides come in.
I wanted to ask about that, yeah. The sources kept highlighting the material they use for the high-frequency diaphragm. They say it has less mass. Why is the actual weight of that tiny part so important?
It's all about inertia. Think of that like this. If you're driving a big semi-truck and you slam the brakes, it takes a long time to stop, right? But if you're in a Formula One car, you stop instantly.
Oh, okay. The heavy speaker cone is the truck. It has momentum.
Exactly. It creates this smearing effect on the sound because it literally can't stop and change direction fast enough.
So by making the diaphragm lighter, they're increasing what they call transient speed. It can start and stop on a dime.
Spot on. That low mass lets it catch the sound of a twig snapping or like a really breathy vowel with zero overhang. It's about texture, not just volume.
Which is funny because the parts inside are like a Formula One car, but the whole box is an absolute tank. The total weight is 167 pounds. That's over 76 kilos.
It is a beast, but it's a skinny beast.
Oh, right. The shallow depth. I saw that. Only 20 inches deep.
And that's a purely practical decision. That space behind the movie screen is incredibly valuable real estate. It's tight back there. So they need a cabinet that is heavily braced with MDF, so the box itself doesn't vibrate and add noise, but it has to be thin.
Speaking of installing it, this was the part that really surprised me. I've set up a lot of speakers in my time, but I have never used an aiming sight.
Huh, that's my favorite feature.
The manual reads like it's for a sniper rifle.
It basically is. It's part of the pan and tilt bracket. See, low frequencies, that building collapsing, they're omnidirectional, they fill the room. But high frequencies, that whispered dialogue, they are like laser beams. So directional.
So if you don't point the speaker quite literally at the audience's ears, they just won't hear it properly.
They'll miss it. I mean, if that coaxial neodymium driver is off by just a few degrees, the people sitting in the back corner seats, they're just going to hear a dull, muffled version of the sound. All the clarity is gone.
So the installer is actually up on a ladder, looking through a sight, tilting the horn up or down 10 degrees, panning it, just to lock onto the seats.
That's how they ensure audio integrity, as QSC calls it. It makes sure the person with the worst seat in the house gets the same clear experience as the person dead center.
It just really drives home the difference between being loud and being accurate.
Yeah.
You have this massive 167-pound box, but its performance comes down to a tiny lightweight part and a literal crosshair.
That's the whole paradox, isn't it?
Yeah.
It takes brute force to fill the room, but it takes surgical precision to make it intelligible.
It definitely makes you think. I mean, it leaves me wondering if engineers in cinemas are using actual sights to aim sound waves at our heads. Just how much detail are we all missing at home, where our speakers are just kind of pointing vaguely at the sofa?
That's a scary thought for any audiophile.
Something to think about. Thanks for listening to this deep dive, and we'll catch you on the next one.